and this problem is popularly known as remote operation program. So hello everyone, this is Easy Automation here, and today we are going to talk about that one program which blew my mind for whole 2 days. Yes, you heard it right. Whole 2 days. But I am here to answer that question in few minutes. So let's get started with the problem statement. So the problem statement is very simple. You have one input and one output, but the conditions are, so there are two instances in this program where in first instance, whenever you toggle the switch on and off for first time, the output should go on, and whenever you toggle and untoggle the switch for second time, the output should go off, and the cycle should repeat continuously. And this problem is popularly known as remote operation program because the program is going to act like there is one remote in your hand. Like you can imagine the AC or TV remote, and whenever you want to turn on the AC, you will just press that button and release that button, the AC will go on, and whenever you want to turn off that AC, you will just simply press the same button for second time and release that one, then your AC will go off. So this is the problem statement for our today's program. Now let's start to answer this question. So for creating this program, we need two rungs. I will just add two rungs here, and I will add one NO contact here and one output coil here and one branch instruction here, and I will just put this output coil in the branch instruction, and I will just add one NC contact here with our output coil. So this arrangement can give us the triggering pulse which will be used for turning off and on the output. So I will just create that logic here in the second rung. So for that I need one NO contact here and one NC contact with it, and I will need one branch instruction here, and I need to put this NO and NC inside it, and I need to add another NO contact with parallel and one NC contact as well, and we need one output coil here. So this logic will be our remote program's main logic. So I will just give the address. I will name it as button. So this NO contact will be our button by which we are going to turn on this output. So I will just give the output address and I will name it as AC. So this output will be called as AC, and this will be our button. And for these outputs, I will just give the memory bits B3 colon 0 slash 0, and for second output I will just give the another bit address about which I have taught in my previous video. So if you don't know about memory bits, you can check out my previous video so that you can get the idea how to use these memory bits. And I will just use this memory bit here for our NC contact, and at this memory bit we are going to get the trigger pulse. So I will just copy this trigger pulse bit address to our NO contact of second rung, and I will just copy this one here for NC contact as well, and for this NC contact we need to copy this output coils address, and for this NO contact as well we need this address. So this is the total program for remote function. Yes, this much only, no any complexities, but the actual thing happens when we run this program. So let's verify. Now our program is in ideal condition where our inputs and outputs are at its ideal condition. Like these NO contacts are NO and NC contacts are NC. So let's imagine this button as your AC remote's button. So now I will just press this button and our AC is on, and if I release this button, our AC is still on. But if I want to turn off this AC by that same button, then I need to press this again and release this one. So our AC will off here. So I think you got the point how it is working. So I will just explain how it works. So the idea is very simple. The compiler will read this program from upper side to lower side. So that's why our this bit will go high before this one, and whenever this bit goes high, this bit is low. But when this bit goes high, it will just immediately cut off the supply for this bit. So that's why this bit has only few milliseconds to blink. So that's why this bit gives us the triggering pulse, and that will be used for this NO contact and this NC contact as well. So now you know how this trigger pulse is generated. So now I will just explain how this output is going high and low using that trigger pulse. So you know the trigger pulse is generated, and that trigger pulse will turn turn this NO contact to NC, and by making this contact NC, the supply will go through this and this NC contact as well, and this NC contact is still NC because the output is not on yet. So whenever the output will go on, this NC contact will become NO. But now here our output is off, so that's why our supply will go through this NC contact to our output, and then our output will go high. And as the output goes high, then our this NC contact will become NO, and this NO contact will become NC, which will create a holding. And I think you have got a question that we are going to give a trigger pulse for this NC contact as well. So why this NC contact won't break the supply for our output coil? So as I said before, the program is compiled from upper side to lower side. So that's why whenever I give the trigger pulse first comes to this NO contact, then the output will go high, and before the output goes off, this pulse has gone off. So that's why this NC contact will become NO again, and our output will remain high. So this was the explanation for turning on the output, but for turning off the output, we have another conditions, like you know about the triggering pulse. So for first triggering pulse, our output will go high, and for second triggering pulse, our output is going off. So how the output is going off, now I will just explain to you. So I have turned on the output, so our output is on now, and if I toggle this bit high, then our output will go off, because the condition happening here is, so whenever I am toggling this bit high while our output is on, the trigger pulse is generated here, and the trigger pulse will come here at this NO contact, and this NO contact will become NC. But as our output is on, this NC contact is became NO, so that's why that trigger pulse will go low here only and will not pass through this NO contact. But that trigger pulse then comes to this NC contact, and which will turn this NC contact NO, by which our supply will break here and our output will go off. So this was the idea behind the off condition. So I hope you got the point and took the notes, and whenever somebody asks you about the remote function, you will just need to stick this answer on their face. And if you like the concept, make sure to hit that like button, and if you learned something new, just comment yes. And if you want your friends to know about this concept, you need to share this video to them, and you need to tell them to subscribe our channel, because we want to hit the 100 subscribers before getting into monsoon. So help me reach this goal. And with that being said, I will see you in the next video. Till then, keep exploring my previous videos so that you get better understanding about PLC programming. I will see you in the next one. Bye.